Living in Mars. Everyone thinks the next living planet is Mars. But what will happen if we move to Mars? What will be the consequence after that? Let's find out. Conditions on the surface of Mars are closer to the conditions on Earth, in terms of temperature and sunlight, than on any other planet or moon, except for the cloud tops of Venus. However, the surface is not hospitable to humans or most known life forms due to the radiation, water, greatly reduced air pressure, and an atmosphere with only 0.16% oxygen. Human survival on Mars would require living in artificial Mars habitats with complex life support systems. One key aspect of this would be water processing systems. Being made mainly of water, a human being would die in a matter of days without it. Even a 5 to 8% decrease in total body water causes fatigue and dizziness, and a 10% decrease in physical and mental impairment. A person in the UK uses 70 to 140 liters of water per day on average. Through experience and training, astronauts on the ISS have shown it is possible to use far less, and that around 70% of what is used can be recycled using the ISS water recovery systems. For instance, half of all water is used during showers. Similar systems would be needed on Mars, but would need to be much more efficient, since regular robotic deliveries of water to Mars would be prohibitively expensive, the ISS supplied with water 4 times per year. Potential access to on-site water, frozen or otherwise, via drilling has been investigated by NASA. Effects on human health. Mars presents a hostile environment for human habitation. Different technologies have been developed to assist long-term space exploration and may be adapted for habitation on Mars. Physical effects. The difference in gravity may negatively affect human health by weakening bones and muscles. There is also the risk of osteoporosis and cardiovascular problems. Current rotations on the International Space Station put astronauts in zero gravity for 6 months, a comparable length of time to a one-way trip to Mars. Radiation. Because of so much radiation reaching Mars' surface, the planet has lost its inner dynamo despite its far distance from the Sun compared to Earth. Due to this, Mars has a weaker global magnetosphere than Earth does. Combined with a thin atmosphere, this permits a significant amount of ionizing radiation to reach the Martian surface. There are 2 main types of radiation risks to traveling outside the protection of Earth's atmosphere and magnetosphere: galactic cosmic rays, GCR, and solar energetic particles, SEP. Earth's magnetosphere protects from charged particles from the Sun, and the atmosphere protects against uncharged and highly energetic GCRs. There are ways to mitigate against solar radiation, but without much of an atmosphere, the only solution to the GCR flux is heavy shielding amounting to roughly 15 centimeters of steel, 1 meter of rock, or 3 meters of water, limiting human colonists to living underground most of the time. Psychological effects. Due to the communication delays, new protocols need to be developed for crew members' psychological health. Researchers have developed a Martian simulation called HI-SEAS, Hawaii Space Exploration Analog and Simulation, that places scientists in a simulated Martian laboratory to study the psychological effects of isolation, repetitive tasks, and living in close quarters with other scientists for up to a year at a time. Computer programs are being developed to assist crews with personal and interpersonal issues in absence of direct communication with professionals on Earth. Current suggestions for Mars exploration and colonization are to select individuals who have passed psychological screenings. Psychosocial sessions for the return home are also suggested and rodent people to society. So, what do you think about becoming the citizens of Mars? Can we come up with a brainstorming solution? Let us know if you have any ideas for the problems we will face on Mars.